Hello viewers, my name's Alan and welcome to my home workshop. In this video I want to talk about my benchtop belt sander. It's a pretty ordinary piece of kit. It's a toy really, but they're pretty common and I've seen them lurking in the background of quite a few workshops and in the videos that we see on YouTube. Really I wish it was much more like the big Wiltons and that we see in videos, the video channels of Keith Fenner and Adam Booth and other well-known YouTubers. But it's the one I've got, and I thought I'd try and improve it and make it a bit more useful for my purposes. So I bought this benchtop combination disc and belt sander quite a while ago, but realistically it hasn't proved as useful as I'd hoped. One of the limitations is if you try to do anything with a compound angle, yes, you can tilt the table this way and then you can move this that way, it gets you some sort of a compound angle, but it doesn't have any rigidity to start with, so that's an issue. Also, because it's working with the disc sander, there's an inherent limitation here, because the disc runs much faster feet per minute or feet per second out here than in there, and the disc runs in the opposite direction here. So realistically you can only use about 1 inch or 2 inches of the disc. And the other thing is, of course, that the grit on the disc is fixed according to the thing stuck on here, and changing it is a pain because you have to rip off this self-adhesive disc and put another one back on. It isn't easy to change. In contrast, of course, the belt's very easy to change. You just let the tension off the belt and then it's easy to slip the belt off and put another one on. So it's easy to change the grip. But this one doesn't have any way of doing a compound angle. You've got 90 degrees and that's it. So I'm looking at this and thinking, well, what can I do to improve it? So ideally what I'd like to have is a vertical belt sander with a cast iron table properly supported and some good rigidity and capable of doing serious work. In short, a proper tool rather than the toy that I have. But still, I have the toy, so I had to have a look and see whether or not I could modify it and make it more suitable for doing some useful work. So when I started looking around the machine, I noticed a couple of interesting things. First is there's a hole here with a locking screw, and I'm thinking, maybe the table that's associated with the disc can be mounted here. But why? Go around further and I realised that the belt apparatus is designed so it can swivel up 90 degrees and be vertical. And that sounded a lot more useful. If you remove these two screws here, you can see there are two socket head cap screws here, Allen screws people often call them, and I thought, okay, well if we loosen that up then probably, yes, we can stand this vertically. So now we're getting somewhere. With that mounted vertically, if it was possible to mount the compounding table here, suddenly this could be a whole lot more useful. And it turns out that that is the case. If we remove this rest, I suppose you'd call it a sanding rest, take that off. And remove the compound table from here, we can in fact mount it here. Now this is starting to look a lot more useful. So another cap screw under here. If we slacken that off, move that up there, I'm thinking, okay, now we're cooking. But it's still not very good here. So I think what's needed is some sort of a brace to come from here down to here with some sort of pivot arrangement, so the it supports the table but still allows it to pivot. So that's what I've done, and I'll show you how. Okay, so the first thing I needed was some way of attaching a brace from here to the machine, and to that end I made up a piece of this bracket here. This is 3/4 inch or 20mm square mild steel, and a 5/8 inch or 16mm round bar, which is just pressed into a close fitting hole in the end. And this is mounted into 2 holes drilled and tapped into the body of the machine. And held in place with a couple of cap-head screws. The washers on the back are because this isn't flat. Put that in there. The other one. And that provides a mounting bar here, which runs in parallel to this one, so to the original piece. So now we need some sort of a support arm here. Now this bar isn't in the same plane as the side of the table, so we need to come out this way a little bit before we can go up, and that's what this piece does. Now to go up to the table, we use this piece. Like that. And I'll show you these pieces in a bit more detail so you can see exactly how I made them, but that provides the ability to tilt and position the table while keeping it quite rigid. So looking more closely at the components that go into making this support for the supplied table, the vertical piece that gets bolted to the machine is 150 long, and as I said, it's 20 square. The bar, horizontal bar sticking out, is 90 plus the bit which is let into the vertical piece, and it's drilled and counterbored for a 6mm cap screw, pair of 6mm cap screws. So that's that piece. The next bit that supports the vertical element is again 20 square by 70 long, and it has 2 5/8 or 16mm holes at 90 degrees with a slot done with a slitting saw, so it makes a clamp on the bar. So it'll go on like that. Two screws like that. The vertical piece, the post, is again 16mm diameter or 5/8 diameter. This is a piece of 3/4 inch square hollow tube, which is, as it turns out, a convenient fit over a 5/8 diameter round piece, with obviously a hole in the end to support the table. Obviously that goes in there. Now when it comes to fitting this to the table, I've used a 10mm or 3/8 I guess cap head screw, and where that goes through the aluminium table, it's a bit of a stress point, so I wanted to support it with a piece of steel. This is a wedge. It's not parallel sided, it's actually a 93-degree included angle, and that's machined and fitted so it will go sit just there. Then when this screw comes through, if I put it in the correct way around it would help. It only fits one way around. Bolt through, and then out in the spring washer just to keep a bit of tension on it, so we can have it adjusted to to rotate around this pivot point, but have a bit of resistance so it doesn't flop about. Okay. Now, of course, another aspect to this that's actually very important for the pivoting to work correctly is that the support, or the attaching bolt here, is in exact alignment with the axis of the original arm. If they're not, when you try and swivel it, of course it will put force on and twist it. So in drilling the hole for this bolt, I actually removed this original support arm, and to do that I had to actually bring it back out through here, this notch. So that's it really. Actually, of course, it goes that way around as fitted to the machine, but that's it all laid bare, and it was a very easy project to make. But I'll show you it all fully assembled now, and you can see that it makes everything much more rigid, easy to adjust and rigid. And there you can see how it all fits back together. So that. And it's just a matter of adjusting to get all the to get the table square and so on. And we'll show you how we do that. Something like that. And so with the screws all done up and it's all correctly realigned, it's easy now to move about, swivel to any angle that you like. And even though it now pivots quite easily, when it's done up, it is in fact now a huge improvement over the way it was.